So this is question 3 of 2008. Okay. Students set up an experiment to investigate circular motion. Cool. They use a battery-powered model car. So as I read this, I don't think of anything of that. Okay, I know it's in a circle. That's all I've gotten. The car is connected with a string to a fixed point as shown in figure 3a. Okay, cool. That's cool. As a diagram of the experimental arrangement they use is shown in figure 3b, where y represents a fixed point and x represents the car. So this is the center, y, and this is x. Okay. So as you read along, try and transcribe that bits of information into something you can use. The car has a mass of 2.4 kilograms. It moves at a constant speed of 2.0, around a radius of 1.6. If you put it all along here, it means you don't have to look back up so often, because you want to be fast. It's important to be fast. What is the tension in the string? You must show you're working. So first of all, we know it's moving in a circle. So therefore, we just use our formula of this cheat sheet. But force equals mv squared on r. And it's a centripetal force. Okay? So the tension in the string, like we look at this situation and we think, what's holding this car inwards? It's only the tension in the string. Okay? And we know because it's going in a circle, if that's the only force, it must equal this. Because to be going in a circle, you must have a force equal to this going inwards. Let me try and explain it again. To be in a circle, you must have a force going in, and we know in this situation, there's a tension going in, and nothing else. That's the only thing pulling in a circle. So they must be equal. So mv squared on r equals t. Or just let me get my calculator. So I'm knocking you over the place over there. Critical battery, yes I know. So m is 2.4 times v squared is 4 on 1.6. 6. So it must be 6 newtons. I just checked that. Everything was in the right units. Meters per second. Meters. Yeah. Good. 6. Okay. Which of the arrows best indicate the direction of the resultant force on the car when is it at point X? So resultant, I believe, is more or less the same thing as net in this situation. So we're thinking of the resultant force on the car. It's like, what must be the net force in this car? Well, if net force was going this way, this car would be going like that. If it was not going this way, it would be going like that. If it was going this way, we know it's moving in that direction. But if it was going this way, it'd still keep going in a straight line. The answer is, because it's moving in a circle, the only acceleration must be inwards. Or the only force must be inwards. And the acceleration and force is given again by v squared on r. Acceleration or force equals mv squared on r. So the answer is P. Must be inwards. I think that's it. Yep. Awesome.